Hello, my dear students. Myself Raj Kalia, working as a mathematics professor in Vrindavan group of institutions. Today I am going to teach you CD formula. We also call it as transformation formula. It's very simple. With this I will do few sums that will finish our trigonometry portion. Now we have done already sin A plus B plus sin A minus B. These identities we have done equals 2 sin A cos B. Sin A plus B minus sin A minus B is 2 cos A sin B. Cos A plus B plus cos A minus B is 2 cos A cos B. Cos A plus B minus cos A minus B is minus 2 sin A sin B. To prove CD formula, we will put A plus B equals C, A minus B equals D. Now add the two. 2A C plus D by 2. 2A is C plus D. Thus A will come out to be C plus D by 2. Then by subtracting A we can cancel. 2B equals C minus D. Thus B equals C minus D by 2. We have got the value of A and we have got the value of B. We have got the value of A, we have got the value of B. Now in all these four identities, now in the first identity, sin A plus B plus sin A minus B equals 2 sin A cos B. For A plus B, put C. For A minus B, put D. Thus sin C plus sin D equals 2 sin. For A, it is C plus D by 2 cos. For B, it is C minus D by 2. Thus we have got the identity sin C plus sin D equals 2 sin C plus D by 2 cos C minus D by 2. This is what we called CD identity or transformation. We are transferring sum to the product. Here we are getting the sum. Their answer is in product. Now second one, sin A plus B minus sin A minus B equals 2 cos A sin B. Sin A plus B. A plus B is C minus sin A minus B is D equals 2 cos A. A for C plus D by 2. Sin B. B for C minus D by 2. So thus we have got the identity sin C minus sin D equals 2 cos C plus D by 2 sin C minus D by 2. Again we are converting minus to the product. Then third is cos A plus B plus cos A minus B equals 2 cos A cos B. Now A plus B put C, will get cos C. For A minus B put D, A for C plus D by 2, so thus cos C plus D by 2, B for C minus D by 2. Thus we are getting cos C plus D is 2 cos C plus D by 2 cos C minus D by 2. And cos C minus cos D minus 2 sin A sin B. Two cos C plus D, sorry, A plus B. Here I have written directly the identity. It's cos A plus B minus cos A minus B equals minus sin A plus B. Cos A plus B minus cos A minus B equals minus 2 sin A sin B. For A plus B put C, A minus B put D minus 2. For A it is C plus D by 2. For B it is C minus D by 2. So like that we are getting 4 CD identities. Sin C plus sin D is 2 sin C plus D by 2 cos C minus D by 2. Sin C minus sin D 2 cos, there it is first sin, here it is first cos. C plus D by 2 sin C minus D by 2. Then cos A plus B cos A minus B. We know this identity is 2 sin A cos B. So then again put the identity, so put the values, and we are getting 2 cos C plus D by 2 cos C minus D by 2. Cos C minus cos B minus 2 sin C plus D by 2 sin C minus D by 2. Here we can write one more identity for this, that is 2 sin C plus D by 2. Here we can write sin D minus C by 2. So both are correct. Either put negative sign outside and then C minus D by 2, or with sign put D minus C by 2. So these are the 4 CD identities. So learn it. These are very important for the conversion, and always you will find one sum there. So I am going to do now some sums. See, the sums are related to CD identities are very simple. Show that cos 70 plus cos 50 minus cos 10 equals 0. Solution LHS. is cos 70 plus cos 50 minus cos 10. General tendency is to club the higher angles. 10 is smaller one. Avoiding that, we are getting cos 70 plus cos 50. Use CD identity for cos C plus cos D. 2 cos C plus D by 2. Cos C minus D by 2 minus cos 10 degree equals 2 cos 120 by 2 60 degree cos 20 by 2 10 degree minus cos 10 degree. 2 cos 60 degree. Value of cos 60 degree from the standard angle is 1 by 2 cos 10 degree minus cos 10 degree. This is what we can cancel. Cos 10 degree minus cos 10 degree equals 0 equals RHS. So therefore cos 70 plus cos 50 minus cos 10 equals 0 degree. So like that you are supposed to prove. Our general tendency is to start with the higher angles. So see the next sum. See this sum. Sin theta plus sin 3 theta plus sin 5 theta over cos theta plus cos 3 theta plus cos 5 theta. We want to prove it equals sin 3 theta. In this sum, sin theta and sin 5 theta we will collect, because when we will add and divide by 2 it will come to be 3 theta. Similarly in the denominator, theta plus 5 theta is 6 theta, divided by 2 will give us 3 theta. So it is same as cos, means triple angle, 3 theta, 3 theta. Our aim is to get it here 3 theta for this. LHS sin theta plus sin 3 theta plus sin 5 theta cos theta cos 3 theta cos 5 theta. What we will do? Sin 5 theta plus theta, sin 5 theta plus sin theta plus sin 3 theta cos 5 theta plus cos theta plus cos 3 theta. Use the identity of sin C plus sin D. 2 sin C plus D by 2, that is 5 theta plus theta, 6 theta by 2, that is 3 theta. And sin C minus D by 2, 5 theta minus theta, 4 theta by 2, that is 2 theta. 2 sin C plus D by 2, sin C minus D by 2. Plus, here we have sin 3 theta. Similarly in down, 2 Sin cos c plus cos d, 2 cos c plus d by 2, 5 plus 1 6 by 2, that is 3 theta. Cos c minus d by 2, 5 theta minus theta by 2 is 2 theta, plus cos 3 theta equals sin 3 theta. We can take common. We are with 2 sin 2 theta plus 1 in the denominator. Here I think I have used the identity wrong. It's 2 sin c plus d by 2 cos c minus d by 2. Here it should be cos c minus d by 2. Sin 3 theta we can take common. Here we will get 2 cos 2 theta plus 1. Here we can take cos 3 theta common. 2 cos 2 theta in the denominator plus 1. Then this is what we can cancel. We are with sin theta by cos theta, that is tan 3 theta equals RHS. So hence sin theta plus sin 3 theta plus sin 5 theta over cos theta plus cos 3 theta plus cos 5 theta equals tan 3 theta. Hence proved. So just you have to apply CD identity. Why I have taken this adjustment? Because sin 3 theta is given. Theta plus 5 theta will give us 6 theta. When we will divide it by 2, it will come out to be 3 theta. Similarly here, theta plus 5 theta is 6 theta, divided by 2 will give us 3 theta. So chances of combination are there, which we are taking it common and getting it. So like that you have to think how to start this assignment. Show that cos 20, cos 40, cos 60, cos 80 is 1 by 60. LHS cos 20, cos 40, cos 60, cos 80 can be written as cos 20, cos 40, cos 60 is 1 by 2, cos 80, cos 80, 1 by 2. Collect higher angles. Cos 80 degree, cos 40 degree, cos 80 degree, cos 40 degree. Then it is cos 20 degree equals Put it as 1 by 4 into 2. It will give us 1 by 2. Divide by 2 and multiply by 2. Cos 80, cos 40, cos 20. 1 by 4. It's 2 cos A cos B. Use identity cos A plus B plus cos A minus B. 2 cos A cos B is cos A plus B plus cos A minus B. Cos 20 degree equals 1 by 4 cos 120 cos 40 cos 20. 1 by 4 cos 20. 180 minus 60. Second quadrant, it will come out to be negative. Minus cos 60. Plus cos 40 cos 20. Cos 120 degree equals minus cos 60 degree, or you can write it as cos 180 minus 60, thus it is minus cos 60. So we will get 1 by 4 cos 60. Value of cos 60 1 by 2 plus cos 40 cos 20. Multiply it, we will get minus 1 by 8 minus 1 by 8 cos 20 plus 1 by 4 cos 20. 1 by 4 cos 20 and 40. See this line. Minus 1 by 8 into cos 20. 1 by 4 cos 40 cos 20 equals minus 1 by 8 cos 20 plus divide by 2 and multiply by 2. So we will get 1 by 8 and 2 cos 40 cos 20 minus 1 by 8 cos 20 1 by 8 cos A cos B, 2 cos A cos B, there is cos A plus B, 40 plus 20 60 plus cos A minus B, 40 minus 20, that is 20 degree. So thus we will get it as minus 1 by 8 cos 20 plus 1 by 8 cos 60 is 1 by 2 plus 1 by 8 cos 20 degree. Minus 1 by 8 cos 20 and plus 1 by 8 cos 20 we can cancel. Thus it equals 1 by 60. So equals RHS. So therefore cos 20, cos 40, cos 60, cos 80 is 1 by 60. Hence proved. So like that we can prove it. Prove that sin 6a, sin 5a, sin 3a, sin 2a, cos 6a, cos 5a, cos 3a, cos 2a equals tan 4a. LHS. Make the pair so that the sum should be same. Just pair sin 6x with sin 2x. That is, write it as sin 6x, sin 6a plus sin 2a plus sin 5a plus sin 3a. 6 plus 2 8, 5 plus 3 8. Similarly, cos 6a plus cos 5a. Cos 6a plus cos 2a. Cos 5a plus cos 3a equals sin c plus sin d. 2 sin c plus d by 2 cos c minus d by 2. 6 minus 2 by 2. Add and divide by 2, subtract and divide by 2 plus 2 sin c plus d by 2, that is 8 by 2, cos 2a by 2, that is a. Similarly here, c plus d cos 8a by 2, that is 4a, cos 6a minus 2a, 4a by 2, that is 2a, plus 2 cos 8 by 2, that is 4a, cos 2a by 2, that is a. So this is what we will get. Equals, now sin 4a and 2 sin 4a we can take out. Cos 4a, cos 4a we can take out. In the numerator, common is 2 sin 4a. Cos 2a plus cos a. 2 cos 4a. Cos 2a plus cos a. Cos 2a plus cos a, cos 2a plus cos 2a we can cancel. 2 we can cancel. We are with sin 4a by cos a, that is tan 4a. So therefore sin 6a plus sin 5a plus sine 3a plus sine 2a over cos 6a cos 5a cos 3a cos 2a equals tan 4a. So that is how we can put this sum, and at last, as usual, if you feel I am working for you people, I am making math easy, and if you like it, kindly subscribe, press the icon bell and like it. Thank you. Good night.